If we have a function that's a sum or a difference of two other functions, in this case we're saying a function u plus or minus a function v, and we know how to take the derivatives of each one of those individual functions, then the derivative of that sum or difference is just the derivative of each one of the pieces, either added or subtracted. In this next problem, we're going to take the derivative with respect to y of h of y if h of y is 7y cubed plus 2y squared. So we're going to use all the same rules we've been doing before, except now they're going to be y's instead of x's or t's. The first thing I'm going to do is I'm going to go ahead and put in place of h of y exactly what it is, and I'm going to notice that this is a sum. Because it's a sum, the rule that we've been talking about here says we just take that sum and we're going to take the derivatives of each one of the pieces. That was what we would call the sum rule. Notice that there's a constant in each one of these individual derivatives. To do those, we're going to pull the 7 and the 2 out in front. So we're going to take 7 times the derivative of y cubed plus 2 times the derivative of y squared. And to do those derivatives, all we need is our power rule. So the derivative of y cubed is 3y squared. The derivative of y squared is 2y. And now when I multiply my numbers out, I get 21y squared plus 4y as the derivative of h of y. Notice that I've really broken these steps down into fairly small increments. Once you get practiced with this, you'll probably be able to do most of this in your head, and you'll just be able to look up at what we have here and say, oh, derivative of y cubed is 3y squared times 7 gives us 21y squared. Derivative of y squared is 2y times the 2 gives us 4y. You won't have to go through all of these steps that I'm showing. Find the derivative with respect to x of x to the 10th minus 2x to the 4th plus a. What we need to be careful about here is we're taking the derivative with respect to x. What that means is any other letter that you see in here represents a constant. So to take this derivative, I'm going to take the derivative of each one of the pieces. And since the first two terms were subtracted, when I break it up, there's a subtraction between these. And the rest is just added all together. So I need to take the derivative with respect to x of x to the 10th. The constant's out in front here, so minus 2 times the derivative with respect to x of x to the 4th plus the derivative with respect to x of a. Well, the derivative of x to the 10th is 10x to the 9th. The derivative of x to the 4th is 4x cubed, and I've tacked my 2 on there because that's the constant. And a was a constant, so when we take the derivative of it, we get 0. So simplifying, we end up getting 10x to the 9th minus 8x cubed.